Welcome back, students. In today's episode, we'll be looking at how to do a 2x2 ANOVA. This is a factorial ANOVA where we've got two independent variables and one dependent variable. In this particular example, both factors will be between subjects designs, although you can also do a within subjects design or a mixed design, one factor between and one factor within. In this particular example, we're going to go to Analyze and General Linear Model and Univariate, because again, we're not doing anything repeated or with mixed subjects. We're going to use Class 2, that's upperclassmen versus underclassmen, as a fixed factor, and we're also going to use gender. So we've put our independent variables in as fixed factors, and now we can look at whether those groups differ in one of our outcomes. In this particular example, we will look at whether there are class differences and gender differences in, say, academic adjustment. Under plots, we want to ask it for one of the factors on the horizontal axis, or abscissa. We're going to do class here for that one, with gender as separate lines, and add it. We can do a line or bar chart. I'm going to do a line chart since class here tends to move up in age, is like ordinal. And click continue. Then we look at post hoc, and we could ask it for post hoc tests, but those won't make sense here because we only have two groups in each category. So you can click it if you want, but it won't do anything for you unless at least one of your factors has 3 levels. We also could ask it for marginal means. This is what we do if we have a within subjects factor. So we can do like a post hoc test for within subjects. But again, we don't need that here. We do, however, want to go to options and ask it for the descriptive statistics, the effect size, and if you want, the power. Once those are done, we click OK, and we get our output. So we get our descriptive statistics, we get our measures of ANOVAs. Again, we're going to be looking at 3 ANOVAs here, one for class here. Here's our degrees of freedom at the numerator and our degrees of freedom error in the denominator. The F-test for class, and its significance. We did find a main effect here. If we look at gender, with this degrees of freedom in the numerator, this in the denominator, and our F value, it's getting there, but it is not significant. So we do not have a main effect for gender. There's no differences. We then look at the interaction. So this is our third F value for a 2x2 ANOVA with these 2 degrees of freedom, our F value and significance. So again, not quite an interaction. In this particular example, class here is the only thing that's significant. So it turns out that underclassmen here report less academic adjustment than upperclassmen. It seems to get easier when students get older to adjust to the grade expectations and work expectations. Now, this kind of looks like an interaction, but remember that the scale can sometimes be deceiving. So the Wildcat factors are scaled from 1 to 5. If we open up the graph and change that scale of measurement to help see what we were actually asking from 1 to 5 instead of this abbreviated scale that SPSS showed us naturally, now we can tell how it doesn't look so much like an interaction. It just looks like underclassmen struggle a little more than upperclassmen. If you wanted to run it again to see what a bar chart looks like for this data, you could go back in and ask it for a bar plot with the error bars instead. You can do error bars for line graphs too. Some people like them, some don't. Again, same statistics, but our bar charts kind of might help us see that effect a little bit more clearly, that these underclassmen here are a little bit lower than the upperclassmen. So remember, with 2x2 ANOVAs, you can have a main effect for one factor, a main effect for the other factor, an interaction, main effects and an interaction, one main effect and one interaction, or none of the above. So you have to look at the 3 different F values to figure out what's going on for a 2x2 factorial ANOVA.